Okay, that one. All right. So we've now solved our system of equations. There's two equations together, or we had a system of inequalities, and we've solved those by graphing. It's not always convenient to solve those things by graphing. Sometimes when I graph those two lines, or at least the ones you guys have done, we've graphed the two lines, and it's real easy to pick out the point where they intersect. Sometimes when we graph those two lines, it's going to intersect in a fraction. And if I want the exact answer, then I can't get that if I put it on a graph, because I don't know if it's 1/3 or 1/4 or 1/5 or 1/6 or what it is. So instead of solving by graphing, we want some other ways to solve. Okay? We're going to learn two ways: substitution and elimination. If you've done any algebra before, you may have learned these before, but we'll go back over them. Most students, I tend to find like elimination better than substitution, but it is totally up to you. On this test, I'll ask you to do one of each method, just so I know you understand both ways. But then any others we do after that, and we'll do a couple word problems and such with this, you can use any method you want. Okay? So kind of try to practice both of them so you understand them, and then after that, you get to kind of choose which method you like better, okay? And I'll also tell you, like, sometimes certain types of systems are easier with substitution, certain types are easier with elimination, okay? Okay, so substitution starts like this. I've got my system of equations, right? Here's my two different equations. I want to find a point that works for both of those, meaning that if I did graph both of those equations, I want to find the point where those two lines intersect. Right? Bless you. Okay, so what we're going to do is basically we're going to plug one equation into the other one. Okay? Now, before we can do that, the first step is always to solve one of the equations for one variable. Okay? You want to make a smart choice. They say, like, make a smart choice here. And we'll do a little bit of this, but since we're kind of in a rush, we won't talk about this as much. But if I was going to solve one of these equations for one variable, if I chose like this second equation and I decided to solve it for y, eventually I'm going to have to divide everything by 3. And is 4 divisible by 3? So it's going to make a fraction. Is 38 divisible by 3?
Nope.
So it's also going to make a fraction, right? So if I chose to solve this second equation for y, it's going to make a fractions. And I know we don't really like those, so don't choose that one if you don't have to. If I choose this equation and solve for x or y, I don't have to divide by anything because there's no number in front. So that would be my smart choice. Okay, there's not always a smart choice, but if you can make one, then make it. Okay, so solve one of the equations for one variable. So I'm going to pick that top equation, the x plus y equals 15. And I'm going to solve it for a variable. You can solve for x or y. Most people are used to solving for y, so we'll go with that. So if I want to get y by itself, what do I need to do?
Could I put like an imaginary one there?
Sure, you can. Uh-huh.
X.
I need to move the x, right? So I'm going to subtract x on both sides, or 1x. If you wrote it that way, that's fine. Bless you. So then over here, the x's would go away. I'm left with just y equals, and then you can write it how we have been. You can put the x first, or if you just want to write 15 minus x, that's totally fine too. We've been doing this, so I'll stick with that for now. But if you have it 15 minus x, that's fine. Okay. It's back here by Phil if it works. Okay, so that's step one. Done. I have one equation solved for one variable, right? It says y equals. Is it working okay? It's not the best one. Is the air conditioning on? I don't know how it works. It's different in different rooms. It's an old building. Huh? Is that what? No, that does not. It's all right. It's hot and sticky outside. So it's fine. I'd rather be cold than hot. Right? No. Yeah, no. I will. Okay, step 2. I used that first equation, right? And sometimes it helps. Like I'm going to label this. This is equation 1. And I'm going to make this equation 2. So in this one, I used equation 1, right? So now I have to switch. Now I'm going to use equation 2. So I'm going to use that 4x plus 3y equals 38. Right? Now, I want to show you something over here. If you had this equation, 4x plus 3y equals 38, and let's say I told you that y equals 2. Whoops. Right? So just ignore this for a second. If I had this, if I told you y equals 2, could you plug in 2 and solve for x? Right? So I would rewrite that. I'd say 4x plus 3 times 2 equals 38. And then I could go through and solve for x, right? We're going to do this exact same step, except instead of just plugging in a number, I'm going to plug in a whole expression, okay? So what I like to do here is, up here, I solved for y, right? And I found out that y equals negative x plus 15. So now in this equation, it says y equals, right? So I'm going to replace that y with the negative x plus 15. This is going to get substituted in for that y. That's why it's called substitution. I'll show you, okay? So everything else stays the same. I keep the 4x, plus I keep the 3. But now just like up here, when I plugged in 2, I put it in parentheses, right? So instead of 2, though, I'm going to plug in this whole thing. So in parentheses, I'm going to put negative x plus 15. And then I still have equals 38.
So y is basically just another way of saying a negative 1x plus 15.
Yes. I know from the first part that y equals this.
So we technically haven't even changed our equation.
Well, we took this equation and we plugged it into the other one. We're substituting it in there, right?
Yeah.
We're saying from this equation, I know that y has to equal this. So I'm going to take this and I'm going to plug it in for y in the other equation.
So we just multiply it?
Now we're going to solve, right? But that step right there is the one that I tend to find most people struggle with. A way to check your work here is when you get to this step, do you see how now I only have x's? That's a good sign because that means I can solve for x. If you get to this step and you have an x and a y,
That's not good.
then you can't solve it, right? So you need to make sure when you get here, you only have one variable left. Because now I can go through and solve. I can distribute that 3, right? So we get 4x. What's 3 times negative x? Negative 3x. And then 3 times positive 15. Positive 45. And then we're working on just our solving skills, right? Now on this one, my left side of the equation, right side, this 4x and 3x, negative 3x, they're on the same side of the equation. So do I need to add 3x here and add 3x here?
No.
Just combine like terms, right? If I add it here and add it here, I'm doing the same thing on the same side. So I'm just going to combine like terms. What's 4x minus 3x? Just x, or 1x, right? And then last thing, to solve for x, we're going to subtract 45 on both sides. So we end up with x equals, what's that, negative 7? Yeah, negative 7. Okay, we got an answer for x. But remember, when we're solving a system, The answer is an ordered pair. It's an x value and a y value that make a point where those two lines intersect, right? So now that I've found x, I'm going to go back to the first equation. Right? So I'm going to go back to equation number 1, and I'm going to use this one that I already solved for y, right? So I'm going to go back to this y equals negative x, whoops, that's kind of funky, negative x plus 15. And now I'm going to take my value I got for x, and I'm going to plug that in for x.
What's that process called?
Substitution again.
That's still fun.
Yep, it's all substituting.
So we're gonna really pay attention to doing our work this time.
Yes. One step at a time. Always, CJ. Whoops. Wrong one. Okay, so then I get y equals, but then instead of x, I've got a negative sign there. That has to stay the same. But then for x, I'm going to substitute in negative 7 plus 15. The parentheses means I'm substituting in some other value for that variable.
Why don't we keep that negative?
Because this negative is part of the equation, and this negative is part of the value I'm plugging in.
Okay, so that negative isn't like what that is.
Correct. Well, it is, but remember, negative x means negative 1 times x, right? I could put a 1 there, and that's what that would mean. Huh, Mark?
So we should just plug in negative 7 for this.
Yes. Okay. Now, if I have a negative 7, what does that mean?
Positive.
That's a positive 7, right? So that'd be y equals 7 plus 15, which means y equals,
7x plus 15.
where's the x?
Did we not have an x?
I thought that.
Remember, x is negative 7. So I replaced the x with negative 7. There's no more x here, right? We already solved for x. I know what it is. So then y equals 22. 7 plus 15.
So then you
22.
put those as ordered pairs.
So now I can put those two things together. I've got an x value and a y value. So then that means the answer to our system is negative 7, 22.
So all that work just for some coordinates.
What do you mean just for some coordinates?
So,
And so we're not supposed to graph it.
How big of a graph do you want to make? Because look at where these lines intersect, CJ.
Oh, I know that. I'm just saying. I feel like it'd just be easier for you to just graph it.
Well,
Just
yeah,
graph it.
probably. But like, if I made the little graphs I give you guys usually have at most 10 squares
I know
on
I'm
each
saying
side.
I get graphic. And I just do it
But that has to go all the way up to 22. So you got to make a 30 by 30 graph, right?
Why do you make this difficult?
I'm not making it difficult. I'm giving you another way to solve the same problem. That's making it easier.
It's not.
That's what I'm saying.
You're putting too much in like.
I am not doing anything. I am giving you solutions to problems. That's all.
I keep forgetting like how to solve these. Like,
That's what homework and practice is for. Yes, Mark.
So is that
That is your answer.
so you won't be putting anything through the coordinates, like through the order.
That is your ordered pair. That's your answer. Now, if I were to go graph those two lines, that's the point where they would intersect at negative 7, 22. Right? If I wanted, I'm not going to go through this just to save us some time because we've done this, but if you're taking the test and you want to check your answer, you could take that ordered pair. Remember, this is an x and a y, right? And you could plug in to both equations and it should work. Or if you wanted another way to check it, you could go out to Desmos, type in both of these equations up here, and it'll graph it for you. And you can zoom out and move the graph around until you find that point, negative 7, 22. Okay. You can't do that on a test, but you can do that when you're doing homework to check your answers. Or I usually give you the answers on these so you can check them. Okay. Again, The biggest mistake on these are just little like arithmetic sign and solving errors. Okay. I have students all the time that like make a teeny tiny mistake here. Like I could see somebody solving here and leaving off that negative sign, and that's going to mess up the whole rest of your answer, right? But I'm going to notice that when I'm graphing, as long as you show me all of your work and I can see that you still did all of the steps correctly, even though your answer is wrong, you knew the process. That's what I'm grading. So if you just left off that one little negative sign and your answer is completely wrong, I'm still only going to take off a half of a point. Because you know the process, you just made a little mistake back there. Okay? It's not always how it works in real life, but that's how it works for now while we're practicing and learning it.
In real life, you can just.
No, in real life, if you make that little teeny tiny mistake, it costs you hundreds of thousands of dollars.
Yeah.
Or your business, and then you get fired.
Yeah, I guess that process.
Put that in my calculator.
Huh? On what?
What you just said.
What I just said? So before I was a teacher, I worked in the financial industry.
Finance.
Did you get fired?
No, I did not. I worked for a guy who made a mistake one time on a spreadsheet. The rows on the spreadsheet got off by 1, and when we checked them, we only checked like every 20th row or something just to spot check it. Well, within those 20 rows, we had one that was off, and so when we did the trades and bought and sold the stocks we were supposed to, we did the wrong amounts. He has insurance for these purposes, but the mistake that he made cost the company we worked for $80,000. Now imagine if we did that
He got fired.
2 or 3 times. He did not get fired the first time. This is why but he pays for insurance to cover him. But if that happened again and again, then yeah, he'd probably get fired. And at some jobs, it might be the first time that happens, right? But this is not that. This is just learning. So we're allowed to make those little mistakes for now. Okay. Okay, we'll try another one.
Yep.
Yeah.
You know
Okay.
Storage Wars where the guy says, yep.
No, I don't. No. I can't watch those shows. Some of them I can, but not that one. Okay, so same thing.
Hold on.
Should we use the second equation, Ms. Mac?
Who's that? Oh,
So can you divide like by so
Are we talking about the next one? Oh, okay.
number 1,
Okay.
I did
So step 1 is we're going to pick one of the equations to solve for one variable.
I'm thinking numbers. Yeah, 2x minus 3y.
Okay, so if I choose that equation, right? And are you going to solve for x or y?
X.
You want to solve for x. So what I'm going to do is I'm going to look at the x, and I see a 2 in front, which means I'm going to have to divide everything by 2. That's divisible by 2. Is 3 divisible by 2?
Oh wait, never mind. I'm solving for y. My bad.
Okay, but just so everybody else sees, that's going to make a fraction, right? So if I don't have to make a fraction, I don't want to. And same thing, if I divide by 3, I'm going to get fractions.
Yeah.
Now 3 divided by 2 would be 3 halves. You know, you can make it 1.5.
Or both of them.
Right. Well, what about this equation?
How are we gonna do this?
I'll show you. Okay, now on this one, there's no number in front of the x. So that's our smart choice,
So can I do
right? That's the one I should solve for. Okay. Okay, so step 1, I'm going to take that equation, that x plus 4y equals negative 9. I'm going to show you. Why am I solving what?
Why are we solving the 2x minus?
Because if I do that one, it's going to make fractions.
Okay, but we're gonna end up doing both of them, right?
No. This is the first step. I'm only picking one of them to solve for one variable.
Okay, but you said pick one. So why does it matter which one you choose?
Because if I pick that first one, if I solve for x, I'm going to create fractions. If I solve for y, I'm going to create fractions. It doesn't matter. That's fine. But I know how you all are with fractions. So I'm trying to show you that if you pick a certain one, you won't make fractions. Okay? Yeah.
So you're saying you pick that one, so we can add.
If there is a variable anywhere in sight that doesn't have a number in front of it, that's the one you should choose
To solve for?
to solve for. Okay, because that's the easiest one. Cadell, did you have a question?
Yeah, why are there two
because it's a system of equations, and we're solving to find the point where those two lines intersect, remember? Yes? The whole point of everything we've done the last two sets of notes, it's been two equations. We graph them both and see where they cross, right? So same thing here. I'm just doing it algebraically instead of using a graph. Okay, so first step, take that equation. I'm going to solve for x. If I want to get x by itself, what do I need to move?
Minus x.
Leave the x alone. I want it by itself. Get rid of the 4y. Okay, so I'm going to move the 4y to the other side. If I want x by itself, I'm going to leave it alone and move the other thing. So then that's gone on that side. I get x equals, and again, you can write it in either order, negative 4y and minus 9.
This is negative, right? Again, if it was positive, it'd be plus 9.
Since that's a negative 9, it's minus. If it was positive 9, I'd put plus. Okay, so then I've solved for x, and I got this for my x, right? Okay, step 2, I'm going to take the other equation, which is 2x minus 3y equals 4.
Do we have to turn it into y equals?
You do not have to change what it looks like. Okay, that's why I think me and you were confused. Like, aren't we going to have to solve both? We don't. This one I don't have to solve now. I can leave it how it is. I'm going to go back to this. And remember I said x equals something, right? So in this equation, I'm going to take that something and I'm going to bring it over here and I'm going to plug it in for x. Because this says x equals, I'm plugging this in for x. Okay. So everything else stays the same. It's just that instead of that x, I'm going to put a set of parentheses and plug all of this in. It's just like having a number. It's just an expression instead of a number. So I'd get 2, but then instead of x, I'm going to put in negative 4y minus 9. And then everything else stays the same. Minus 3y equals 4. Everybody with me? What are you confused on?
How did you get it's all like messed up?
Specifically,
Like,
do you understand my first step and how I solved for x? Yes. So this says x equals something, right? So now, if I know that x is like 2, I can plug 2 in for x, right? It's just that instead of 2, it's equal to this. So I'm now taking this, and I'm going to plug it in for x. So that's what I did. I rewrote this equation, but instead of x, I plugged in what I know x is equal to. Yes? Okay? And notice this equation, there's only one variable. It's both y's. So now I can solve for y. That's the whole point. Okay? Okay, so where does 4 come from? This equation. I didn't change it.
We were doing the bottom one.
Okay, we solved the bottom one. We got this, right? So then I solved that for x. So now I took that and I'm going to plug it into the other equation. That's this, 2x minus 3y is 4. Right? That's why we have the two equations. We're solving one using the other one. Okay? Okay, so distribute your 2. 2 times negative 4y is negative 8y. 2 times negative 9 is negative 18.
Oh, that's where I'm missing that.
Then I still have minus 3y and equals 4. Pay attention to where your equal sign is. If it helps, you can put that little dotted line there, right? This negative 8y and negative 3y, they're on the same side of the equation, right? So I'm just going to combine those like terms. What's negative 8y and negative 3y put together? Or negative 8y minus 3y.
You just do that. You don't have to do plus 3.
Why am I not doing plus 3y?
I thought it was only if like it was right next to it.
Okay, well, let me show you something. If I did plus, don't write this down. If I did plus 3y, right? Where else would I put plus 3y to match it up with its like term? Negative 8, right? Okay, so now I've done plus 3y, but do you see this? Remember the scale thing we had, right? This is my balance on my scale. So I've just added something twice to the same side of the scale. So I just took my scale and I went like this. It's not balanced anymore. If I'm going to do something opposite like this, if I'm going to add that, I have to do it here, and then I have to do it on the other side of the equation.
Wait, why are we adding it?
Hold on, I'm not.
Okay.
So if I add it here, I would also have to add it over here. But that doesn't get me anywhere, right? I'm trying to put them together. So since they're on the same side of the equation, I don't want to do the opposite operation. I'm just going to combine the like terms and put them together. Remember when we had the pawns? We said if I add one to this side, I add one to this side, right? You just wanted to put two pawns on the same side. And then that would throw our scale off, okay? Instead, all I'm going to do is I'm saying I put negative 8 pawns here, and I also have negative 3 pawns there. So if I put those all together, what do I have? I'd have negative 11 pawns. So I'm just combining those like terms. Manny, what were you trying to ask? Because that's wrong. I said don't write that down. I was trying to, Braden asked why don't we add 3y on both sides? I'm not adding 3y because I'm just going to combine these like terms. If I add 3y here on this side of the equation, then I also have to add 3y over there. And that's not doing anything. That's moving my two y terms farther away from each other. These are on the same side, so I just need to combine them to make a single y term. If they're on the same side, I just combine my terms. If they're on opposite sides, that's when we do the inverse operations. Huh?
So I know we're not supposed to add it, but if we do, would that still be wrong? Or would that just be harder to...
Say that one more time.
I
If you
said-
did add 3y?
Yeah. Would that just be harder?
No, it would just involve more steps. So if I added 3y and moved it over here, then I got to add 8y to move it over there to get it to be with it. And then I would end up with 11y on this side. Right? And then I'd have to move my 4 over there. So you'll still get there. It's fine if you do that on accident, as long as when you do that inverse operation, you're doing it on each side of the equation. Remember, the goal is to get down to one variable term and then solve for that variable. Okay, what's next to get y by itself?
You're gonna add it on both sides, or would it be subtracted on both?
Add what?
Wait, we're talking y by itself?
I'm trying to get y by itself.
Oh shoot, we gotta only do the 18 on the other side first.
Add 18 on both
Yeah, add
sides,
18.
right?
I'm tripping.
Because I've got now my two constants I need to get together. But they are on opposite sides of the equation, right? So now is when I want to do that inverse operation because I want to move it to the other side.
So we're gonna do plus 18.
So plus 18 and plus 18. So I end up with negative 11y equals 4 plus 18 is 22. Last step to get y by itself, divide both sides by negative 11. So we end up with y equals negative 2.
So don't you have to plug that negative 2 back into?
So now we're going to take, now that I know what y is, remember this is a system, so I need an x and a y value. So now that I know what y is, I'm going to take that back over here. See how we kind of make a circle, right? I solve one, I plug it into the other. I solve that, I plug it back into the first one. So now I go back here, and I'm going to do x equals, whoops, -4, but now instead of y, I'm going to plug in, what did we get for y? -2. And then -9.
Wait, oh.
So you
Right.
solve them both. Cool.
And then it's just the numbers, right? Just do the math. -4 times -2 is
-8. I mean, positive.
+8. And then 8 minus 9 is -1. So now I can put those two things together to make my ordered pair of -1, -2. Remember, it's always x comma y. They are not short problems, but you'll get faster at them as you practice. Okay. I will tell you, most times in the future, when we go to use substitution, this first step is going to be done for you. That will make it easier.
It's good. It's so rare. You have no idea.
That's a bad
Put your phone away. Just put it away. Put the phone away.
That's a bad
Put the phone away. All the way.
That's a bad
Okay. One more. We don't need to do the last one, but let's do one more. One more. Okay. Okay. Last one we'll do, and then I'll let you guys
Do the bottom one first.
do what?
Because you said that you do the
Do not always do the bottom one first.
Do the bottom one.
Okay, now hold on. On this one, look at what we have. They both say y equals, right? The first step is to take one equation and solve for one variable. Do I need to do that here? It's already done, right? I already have an equation that says y equals. Actually, I have two of them. So for step one, pick one. It doesn't matter which one you want to do, top or bottom.
Top.
Top one. Okay, so for step one, I need my y equals 3x plus 1. But I don't need to solve it. That step is already done. Okay, because it already says y equals. And it can be y or x. Remember, it doesn't matter which one. Okay, so step two. Nigel. Is that your music or Nigel?
You should hear.
Okay, focus. Okay. All right, step two. I take the other equation, which says y equals 3x minus 7. Okay, so step one, I had y is equal to this, right? So now, since it's y equals, I'm going to take this, and I'm going to plug it in for which variable over there? Y, right? So I'm going to take this, and I'm going to substitute it in for y. Yeah. Just keep watching, and then we'll try one, okay? Keep watching. What part are you confused on?
Like, how do you know which one you start with?
Doesn't matter on this one. And it doesn't matter ever, really. It really doesn't matter. There's a smart choice to make, but in this one, it doesn't matter.
Why do you think it's January?
Because now I'm hot.
It is cold in here.
I'm up here moving around and talking a lot. It makes me warm. Okay, so plug it in. We ready? So I'm going to replace the y with what? 3x plus 1. So I'm going to put 3x plus 1 equals 3x minus 7.
Why is that not in parentheses?
There you go. Is that better? Okay, it's fine. But do I need those parentheses?
No.
I did before because I had to distribute, right? There was a number in front here, so I needed those parentheses to distribute. On this one, there's no number in front to distribute, so I don't have to worry about them, right? Okay, so I could rewrite that as 3x plus 1 equals 3x minus 7.
If we were to graph this, wouldn't it would intersect?
Let's see. So what do I do next?
Get you don't the 3x is like don't they crossed out?
I want to get the 3 x's together, but notice this time the 3 x's, they're on opposite sides of the equation, right? So I'm not just going to combine like terms this time. I have to do those inverse operations. So I'm going to subtract 3x and subtract 3x.
That's 0.
And what happens to our 3 x's?
They're gone.
They're gone on both sides, right? So then all I'm left with is 1 equals -7.
Which is not true.
That's not true. 1 can't equal -7. Sloan, what were you trying to say earlier if we graphed these? So what kind of lines are these when I graph them?
Not
Look at their slopes.
parallel.
They're parallel, right? They have exactly the same slope. So if I were to graph those two lines, they would be parallel, which means they never intersect. And that 1 equals -7 is not true. So our answer here is just no solution.
So it doesn't have a variable, it's just no solution.
If your variable goes away and you're left with a false statement, it's no solution, just like always. Which makes me, actually, I do want to do this last one. Yeah.
Can I pull this up too?
Yeah.
Right. I'll just.
You know how like it's like we're trying to take 0 divided by a number divided by 0. Which one is 0?
You can use a calculator to remind you. Your calculator will do that. If it says error, that means it's undefined. But where are you not allowed to have 0? The top of the fraction or the bottom?
No, my math retake.
I know what you're talking about, but where are you not allowed to have 0? Top or bottom of the fraction? If I have 0 pieces of pizza, you can't have it in the bottom, right? I can do 0 divided by something. You can't do something divided by 0.
You can do one more.
All right, last one. Everybody sees this one and skips it. Why do they skip it? But don't we know how to get rid of the fraction?
No.
No.
Times 2.
Thank you, Cattell. Thank you. Take that fraction and just or that equation and multiply the whole thing by 2. Right? Take this whole thing and multiply by 2. Distribute. What?
What are like dealing with fractions? That's something fractions.
That's not true. I have taught you ways to get rid of them. Your life is fractions.
So are we taking the 2 underneath the y and distributing it?
I'm going to multiply the whole equation by 2 to get rid of the fraction because everybody hates fractions, right? They're just evil. Okay. You could, but I'm not going to. And remember, the whole idea is we want one of our equations solved for one variable, right? If I get rid of this divided by 2, then it'll be solved for y. Okay, so our step 1, I took that equation. If I multiply it all by 2, 2 times y over 2, that would just be y. It'd be 2y over 2, and then the 2's would cancel, right? Because this 2 and that 2 would cross out, and I'd just be left with y. Equals 2 times 2 is 4, and 2 times -x is -2x. Okay, look, no more fractions. And also, now look, it's solved for y. Our first step is done. We have one equation solved for one variable. Okay, so step 2, I'm going to take my other equation. 6x plus 3y equals 12. This says y equals this thing. So I'm going to take that thing, and I'm going to plug it in for what variable over there?
Y.
Plug it in for y. So I'm taking this over here to the y, and I'm going to plug it in.
Why did we times 2?
To get rid of that divide by 2.
Well, you were the one that came up with that.
Yeah, you were.
I know, but like I thought that you're supposed to do it on both sides.
I did. 2 times that would be y. 2 times 2 is 4. 2 times -x is -2x. Right? Good? Am I good? Okay. All right. So now that's y equals.
Still water all around.
So I'm going to take this, and I'm going to plug it in for y. Put it away. Put it away. Put it away. If you would focus the whole time instead of looking at your phone all the time, then you would help. Right? Okay. Plug it in for y. So I'm going to rewrite this. 6x plus 3, but instead of y, what am I going to write?
The 4 subtracted by 2x, yeah.
Do I need parentheses this time, Eli?
Yes.
Yeah. 4 minus 2x. And then I still have the equals 12. Right? Everything stayed the same as it was up here, except for y. I plugged in what y is equal to. Distribute. So then I get 6x. 3 times 4 is 12. 3 times negative 2x is negative 6x. Are my x terms on the same side of the equation or on opposite sides?
Same.
They're on
So
the
it's
same
12
side of the
equals 12.
equation, so I can just combine my like terms. I don't need to do inverse operations there, right? So a positive 6x and a negative 6x make what? 0x, which is just 0. So they're just gone, right? So then we're left with 12 equals
Infinitely many.
12. Not undefined. That's true, isn't
That
it?
is true.
No, but
Wouldn't it
there's no variable.
There's no variable.
would that make
So,
it infinitely
hold on.
many?
Up here, we lost our variable. Up here, we lost our variable, but it was false. So that means it's no solution. They don't ever cross. On this one, we lost our variable, but this is a true statement. 12 equals 12. So this means that these two lines, if I actually put this in y-intercept form, they're exactly the same line. They're going to be on top of each other. So they intersect everywhere. So this one has infinite solutions.
Okay.
If you want to remember, I showed you this once before. You do not have to write it this way. But we would say the solution is the set of all ordered pairs such that y equals 4 minus 2x. That's the fancy math way to write that. You'll talk about that more in Algebra 2. I'm not going to require you to do this right now, but that's technically what the solution looks like. It's the set of, these brackets tell me the set of. This tells me ordered pairs where I have x comma y. This means such that y equals 4 minus 2x, and that's the line that both of those would look like. This is the important part. If you can at least tell me infinite solutions, that's all I care about right now. Okay. Okay. We got 8 minutes. I want you to try one before you leave, at least. And I'm actually going to cut this short, so we're not going to do all of these.
I got it.
What? There you go. Which ones are we doing?
Let's see.
Holly, Jolly. This time.
Definitely the whole first page. 1 through 4. Let's just do 1 through 8. How's that? 1 through 8.
Take a piece of paper, please.
1 through 8.
Hey, you want to write it?
Yeah, bro.
How's that?
Of the homework.
I'll go 4-0.
So if you, okay, so
Or
see how you
eventually
have,
we'll do my
that's fine. So see how you have a folder right here, with your name on it, right? So right now there's, all that's in there is student focus quizzes. Here's your homework tab if you want it. Oh, there you go.
Oh, now you're there.
So,
That's personality of the show.
I like that shirt. Yeah.
okay,
I didn't
so
know
what
it
you
was
can do
Spacer.
then, is you don't have to do all
It's like a
this. You
collab
can just
of
go
all
here.
I got this at Goodwill for $1.
Goes
Yeah, the same time I got the shirt for
You
$1.
get homework 3.
Hey, I got this shirt for
Right.
like 16 bucks. That's such a steal.
Right.
No, it's pretty small. It's
Pick
good.
your
Quality roof.
Okay,
Do you have that
then
channel
go
for
down
TVs
here
and
and it's
sweatshirts?
a little under.
Oh, yeah. And you what else needs to
I
be
have
laid
three.
out?
Okay, is it good? We gotta do it in the empty space.
Right now.
and paste.
Right, yeah.
Now
Also,
that
that's
copy
nice.
is you can write on it and then
Yeah.
save it here.
Okay.
And then I can see it too. So when you get it done, just let me know and I can create it. Eli, you had a question?
Yes, I do. Okay. So I did this equation
Actually,
two
I was
ways.
probably
Like,
the best
we
game.
do X, then this is the one we did
Solve
in
for
class.
y? Okay.
That's the one
Except
that
for,
we did in
like,
class though.
Yes.
So
2K19
I got
is
this one
prime,
wrong.
Fortnite is prime, Warzone is prime, Minecraft is prime. I don't play as much as I used to, but I
That
used
should
to
be a
use
negative 3/4, shouldn't it? And that should be that's a positive 27.
But you play
But
Roblox.
then, hold on, see how this has an X and that doesn't. So you don't want to add these two. You want to add
Hey, you ready?
the X and the 27.
What's up?
You ready?
Sure.
Oh, no, you're right, I'm sorry. But it'd be 2 minus 3/4.
Are you ready? That's my question.
Because that's supposed to be negative.
So, are you getting
Oh,
money?
no, wait. You did that. You did that.
Flash Royale.
You did. You had mine. You just didn't write your mind.
I beat him 3
You
times.
used to try to do this. Okay, now you're not done. If I wanted to solve for X here,
There you
I
go.
would have to divide by
Pressure's
11
on.
fourths. So what's negative 11 fourths divided by 11 fourths?
What is it?
What's 8 divided by 8?
1.
10 divided by 10.
1.
What's
So
negative 3 divided by negative 3? Negative divided by negative is 1. Now what is negative 3 divided by positive 3?
I did one.
I think that's negative. Yeah, 1.
1, right? Anything divided by itself is 1.
So then that's negative 1.
So your x equals negative 1, which is what we got over here.
Okay.
But now you would take that and you're going to plug it in here to solve for y.
Phil,
I did that better than I thought.
I do like so
You
much.
got
Alright,
it. You just need to, you got to actually
Alright,
do
it's
that
fine.
sequence.
I push my valve like
I also have
You
all
just
those
want me to
last
beat
corrections.
you and then I can run it?
Do I need to like retake the test?
You can retake it.
I believe
Do I
you.
get
I placed the Valkyrie right as you
That
came
just
across the
allows
bridge
you
and
to
then
take the retake.
put it back in my inventory and then
Well, otherwise
Just
you
get
can
it.
come in and retake not knowing any better.
Yeah.
Right? So just let me know if PRT or.
Alright, yeah. I'll set something up.
I won't be here after school today. But I'll be here
I have a
before.
doctor's appointment anyway, so it's.
Do you have a paper I can use?
There's graph paper in the math office.
Yeah.
Yeah, if you go in the math office, under the shelf right here when you first walk in, there's a stack of graph paper. You can get some of that. It's allowed. What is there for?
I'm gonna get the shell. See if I have one first. It's not one of those when you start just grabbing it.
I cannot dare.
That's
I think
okay.
Hey, for 1, did you use the second?
Did some practice on those.
Good. Fine.
If we've got like 3 minutes until class.
The graphing stuff.
Brandon, what do you have next?
Keep doing that, and then on the final, you're gonna see all of that stuff. Okay, so if you have.
We started getting
I'm gonna make a delta map with everything on it. Probably have it.
That's right.
Yeah.
What's it?
This last Friday, and I actually
So Friday, I'll have a big one.
play an PRT.
Are we doing
I wanna
retakes?
start
Are we
getting
doing
ready.
retakes?
Yes.
So we're doing retakes on the other one too?
I mean, there's not gonna be
So graph.
Okay.
did you bring the retake?
No, I'm not yet.
Are there retakes for the newest test?
She said,
Yes.
don't worry, no, it's yours. I'm good.
Take that back up here. Sure, except that said minus. So it should be negative 5. Just like in the other color.
Why are you doing it with
Hey,
A
you know the
and B
song,
now?
It's in the
Why are
Devil?
you making it more difficult?
Want different variables?
Nah.
T, especially a lot of people like, I've purposely
No,
made
no,
a
no,
tail on my T's, so I don't confuse it.
It's- dude,
But if
it's
you don't do
something
that,
you should
I'm next. It's totally different.
You gotta listen.
Yes. How did you get?
It's so good.
I don't like
I'm telling you.
Did everything right.
It's basically like
Five minutes here, and you got your x equals, right? Now this goes back there.
Oh.
That's y. And we will. Okay, right here, it's back. You set it up right. You get your x equals. You don't want to just do
This time I'll have to change your light. You gotta like stop and think about it. Like just listen to the lyrics. It's like, alright.
Yeah, and then once you get that, remember go back and plug it in here.
Love you, Miss Mac.
It's
back. I'll see you in a few.
Since everyone negative, since it's negative one, right?
Yeah, don't divide by negative y. Divide by negative y.
Yeah, I put the X because
Because you want the y there, so you're just gonna get rid of the negative. Remember, anytime you have like a negative variable equals something, you can always just change the signs of everything.
okay.
Miss Mac. What do I do with this?
Okay, so you did this, right? So now you have x
Thank you, Miss Mac.
equals this. So now with your other equation, you're going to take this and plug it in for x. So you go up here, put that in for x. So it's going to be y equals 6 times, fold that one. Okay.
I'm lost, bro. I'm lost.
It takes a minute to get used to these.
How many questions do we leave?
You want to come see me first, POT? I gotta go to class. You guys have class right now? Are you off? Are you off, Aids?